talk, which will be given by Marek Husarik, also about near-Earth asteroids. So please share your screen.
Okay, thank you for introduction. Okay, I see that we have time. I hope that you hear me and you see my presentation. So, let's say laser. My topic of this presentation that is observational findings of 7 asteroids. Here is the picture of our observatory, which belongs to Astronomical Institute of the Slovak Academy of Sciences. It is typical image in winter, and now it is in summer. What we have 2 main telescopes. This is a smaller 61 centimeter Newtonian reflector. We use the CCD S-Big ST10 with Johnson Cousins UBVR filters. What is necessary? This is a field of view, and typical sync about 3 to 5 arc seconds. Another a larger telescope is 1.3 meter Cassegrain Asmis. Here's a focal ratio. This telescope has 2 Nasmyth foci. In the first focus is CCD-FRE, and in the second the focus is actual spectrograph with CCD camera. Typical field of view of for photometry we use a 10 times 10 arc minute field, and this is a resolution. Typical sync with this telescope is about maximum 3 arc seconds. At our institute, we have 3 main departments. The first department is focused on the sun and physics of the solar prominences, eruptions, etc. The second department is is department of the stellar physics. They observe variable stars and exoplanets. And the third department is focused on interplanetary matter. And here are written 2 main objects of interest. We study the physics of comets and asteroids, like surface properties, shapes, rotations of asteroids, or then rate of production of dust and gas from cometary nuclei and chemical composition. And the second main object focus is dynamics of the small bodies. This part is mainly theoretical, and the colleagues here investigate the motion of cometary nuclei, asteroids over the solar system, and they study or they model the meteoric streams, and they try to find parent bodies, and then there is a study of cometary and asteroidal surfaces, and they're trying to find terrestrial analogs in laboratory conditions. And we maintain 4 all-sky-bolide cameras in the European Fireball network with colleagues from Astronomical Institute in Czech Republic. Here I selected some recent activities. We do science here. We are searching and characterize of ordinary and binary asteroids. Binary asteroids we study with the colleagues with the colleague Peter Pravec few years ago, we studied the activity of the asteroid Gold, and now we have on the table another active asteroid, 2005 QN 173. Colleague who is interested in comets. She studied spectral photopolarimetry of bright comets. Here are some examples. Some results are published in papers. Of course, we then observations of interstellar comet Borisov. There is a small project. Obviously, yes, it is a small project to study some Midas with the radar data, or in collaboration with radar colleagues. And here is another, it is like a byproduct or coproduct that we try to search cometary activity for some near asteroids. Here is a list of Midas. I will present some results. Here you can see that we have some cooperation. It is this Arecibo team. This object was observed also with Arecibo. These 3 or 4 asteroids are in collaboration with colleagues from Crimea, from Russia, Tajikistan, and finally I will present some results about asteroid Apophis. So here is the first Midas. It was a very nice object to observe. When I observed it for the first time, I got very low amplitude in my light curve. So I try to find where's the problem, because the literature says that the magnitude is about 1 magnitude. I talk about my result with colleagues from Arecibo, and we try to model this asteroid with radar data and with data from another observatories. Here you can see comparison of modeled and observed data. Here is a picture how it looks like radar data and how it looks like synthetic shape of this asteroid. We found that this asteroid is composed with 2 lobes. This asteroid looks like very similar like Churyumov-Gerasimenko comet. Here are typical sizes or values of the dimensions and typical volume equivalent diameter of this asteroid is about 2.5 kilometers. Rotation pole was located at this position, and this asteroid rotated in retrograde sense of rotation. And here is a period which was confirmed by me and by radar data. These results are published now in PSJ. You can see that this paper is very hot now, only 2 days. The second asteroid we observed is 1998 OR2. This asteroid was one of the big potential hazardous asteroids. Here's a typical asteroid from a typical image from our telescope. It was done in 3 filters. This is the picture from radar. In the archive, I found some light curves and from the year 2009 and 2020. Both are low magnitude or very flat, but my data from phase angles about 60 and 70 degrees contains some features in the light curve. For example, here about near the phase 0.4, there are some changes. There is a AG diagram. I'll try to compute the absolute magnitude and G slope. From polarimetry, I try to estimate what is the taxonomy class. It seems that it is class X in Tolan taxonomy. It was also confirmed by other authors. Then from this data, I try to compute where the rotational pole or the north axis is oriented in the ecliptical system. I got information from this diagram that this asteroid must rotate in prograde sense with communication with Maxim Devogel. Received that really this asteroid rotates in prograde sense. Here is a precise orientation of the pole. Now I have no 3D model because my data are not sufficient. I'm in touch in Maxim Devogel, and we plan to make own publication. Third asteroid we observed is 1998 HL1. This was a very pretty no, it was a pretty challenge to observe this one because it had a very fast movement across the sky. But from our photometry, we received that this asteroid rotates with a period about 12 hours. This is light curve only from my data or our data. Later, I got data from a Crimean observatory, and I tried to put them to my light curves, and the 12-hour rotation was confirmed. Here is a periodogram. On Twitter, I found information that this asteroid rotates with a period about 10 or 11 hours, but this do not fit with my data. So I suppose that this asteroid is really with 12-hour period. Here's a computation of the absolute magnitude. About an absolute magnitude is about 19.19 or 17. This is with fixed G, and this is for various G. I got polarimetric data for this asteroid from Crimea and Terskol Observatory. With this, there are these two telescopes. And what is important information from that this albedo for that asteroid is about 0.35. Later, we found information from Johnston that this albedo is close to our value, and from our photometry we received when we applied Johnston albedo, the size of this asteroid is about 300 meters. When we applied own albedo, it is slightly larger. And what about taxonomy? In this diagram, you can see that this asteroid belongs to S type. Another asteroid 1999 AP10. This was a very good candidate for modeling. It was done with collaboration with Anna Kartashova and Nikolai Kiselov from Crimea. Here are some light curves from different phase angles. I have not written here what is the kind of precise values of the phase angles. And you can see that here's a very flat light curve, and then the light curves has more and more larger changes. There is a calculated absolute magnitude and G-slope, colorimetric observations from our data shows that this asteroid must belong to as complex intolerant taxonomy. This is one picture from the polarimetry. Okay, so this model is constructed only from our data, and you can see here's a model from 3 views, and here is a computed sidereal rotational period, and this period comes to computation to spin axis orientation in the sky. So this is here are the heliocentric coordinates of the North Pole, and you can see here are some synthetic versus modeled light curves. Then I have here 2 asteroids, 2008 AF4. This was done only from a few data because the weather was not good. Here's a light curve which shows me that there was a complication with the lack of data. Periodogram shows me that there are many periods between 3 or 4 hours, but later I found the paper from Warner by Warner Stephens in Minopol and Bilton, that there are really many possible periods. So this is our result, and colorimetry shows me that this asteroid should belong to X complex or Q. Here's another paper where are the values of color indices. So here it is included, but this asteroid was hard to observe due to not good weather conditions. So here is a summary. Yes, as I said, that this asteroid goes to X complex. Another asteroid was observed also. There is 2 light curves, but there is information from Pravets and Warner that they estimate the rotational period more than 70 hours, and there is a possibility that this asteroid is tumbling, but from our photometry we calculated the absolute magnitude and that value, and here is a very not precise estimation of the taxonomy class. Yes, I said this one, that this asteroid has yes, our computation of the diameter shows that it should be less than 1 kilometer, about 88 or 900 meters. Other references says that it is about 700 or 800. We plan to observe it in next year in September, when this asteroid will be about 15 magnitude. So last is one of the most popular asteroids or potential hazardous asteroids. Apophis, maybe you know that last year there was a last chance to get any data before the great approach in 1999. 2029. Our photometry shows us that absolute magnitude is very close to absolute magnitude published in literature. Here is a polarimetric diagram where are these two color indices, and you can see that these colors were computed in each night we observed, and they are compared with the data from Hromakina and Lin. There is no discrepancy or what. As this asteroid belongs to S class, especially SQ. The first or the byproduct is computation of the rotational period. We know that Apophis has the rotational period more than 30 hours, and this is a tumbler. And I try to compute this period from all nights I have at my disposal, and really I got very, very close rotational period, about 30 hours. Here is the periodogram, and what we have, what we know from our photometry, that the diameter is very elongated, or this asteroid is bilobed or pre-lobed. And we got sizes at this interval, and literature says that it is from that values, and effective mean diameter is about 350 meters. This is albedo. Here is absolute magnitude, and we confirm that this asteroid belongs to silicate taxonomy. Thank you for the attention.
Thank you for your talk and for presenting your results. I'm really happy that you have shown the radar data that are not commonly used for asteroid studies. And we are a bit out of time, so we've got time for one quick question, or we can discuss on chat. I don't see any questions, so let's move to